Electronic waste is the world's fastest growing waste stream, rising 3 times faster than world population growth. Collectively, we generate over 50 million tonnes a year. Now, I know you've all been asked to put your phones away, but you just get them out for a moment now. 50 million tonnes is the equivalent to about 277 billion smartphones. And if you put those head to tail around the circumference of the world, how many times do you think they go round? Once, 5, 10, 100? They go round over 1,000 times. And we produce that every single year. My name is Mark Loveridge, and I'm the Business Unit Director for Precious Metals Recovery at the Royal Mint. You probably know us for producing coins, but today we do so much more. We're leaders in precious metals, for coins, investments and jewellery, and we're committed to sourcing our precious metals in the most responsible way that we can. So we consider the role the UK plays in electronic waste. I'm sorry to say we're one of the worst offenders. So bad, we're expected to be the top producer per capita in 2024, next year. And the story around the rest of the globe is not much better. Only a fraction of electronic waste is formally recycled. The rest finds its way into landfill or is informally treated in third world countries where it creates health hazards and releases dangerous toxins into the environment. E-waste is a serious problem, but I see it as an opportunity for us to do better. You say, it contains a wealth of valuable materials. It contains gold, silver, copper, palladium, and rare earth metals. It's important from an ecological and economic perspective that we recover those materials. After all, they're expected to be worth over £46 billion. And the route for collecting those materials where it is recycled at the moment isn't great. We ship it into Europe or into the Far East, where we smelt it at high temperatures, recovering just a small amount of the incoming mass. If we can learn to recycle electronic waste sustainably, not only can we reduce our environmental impact, but we can also create new economic opportunities. And at the Royal Mint, we're doing that drawing on our 1,100 years of heritage, our expertise in precious metals, and our drive to transform for the future. It was the great mathematician and physicist, Sir Isaac Newton, who created the universal law of gravity. You probably all know the story. Back in the 1600s, an apple fell on his head, and it inspired him to develop his universal law of gravity, a concept that changed the course of history, and today is a fundamental law of physics. Less well known is that Sir Isaac Newton was Warden of the Royal Mint from 1696 to 1699. And on Christmas Day in 1699, he took the top job as Master of the Mint until his death in 1727. He was also an alchemist, and that saw him trying to turn base metals like lead into rare and expensive metals like gold. For those not familiar with alchemy, it was a proto-science that was practiced in the Middle East and Europe between the 8th and 17th centuries. As well as trying to turn lead into gold, they also sought to create the elixir of life and to discover the philosopher's stone. Now, know what you're thinking? What a load of superstitious magical nonsense. But actually, Newton's alchemical studies had a significant impact on scientific work. His ideas around the transmutation of metals led to new theories around the composition of matter. And whilst he wasn't able to turn lead into gold, as far as we know, he was able to use that alchemical knowledge to help him develop new techniques for chemical analysis. Today, alchemy is no longer considered a legitimate science. But I think 3 centuries on, Newton would be intrigued to learn that the Royal Mint is employing technology that could be considered in modern alchemy. We have partnered with Exeer, a Canadian Cleantech who have developed a technology for leaching precious metals from the surface of printed circuit boards at ambient temperatures. And we've been focused on developing a clean and safe process to recover as many of those precious resources as we possibly can. We pioneered a mechanical process which deconstructs the board at the very start, creating rich fractions of different compositions of the materials. We then use vision sorting to identify which parts of the board contain gold. Those elements are subjected to the chemistry. And the chemistry is really quick. We leach the gold in just a matter of minutes at ambient temperatures to a level of 4 nines. And what that means is it can be used in a manner of different applications. So for us, initially, that's our gender-neutral luxury jewellery range. But in time, it could find its way into dentistry, medicine, or into new electronics. When the bare board rejoins the board that had no gold on it initially, it goes through various other mechanical processes to make sure we create richer purities of those materials. So we end up with fiberglass, we get copper, aluminium and steel. They're then in a desirable state. They can go into new products or go on for further downstream treatment. And we try to be circular in everything that we're doing. So the chemistry, for example, can be reused up to 20 times before it goes back to the manufacturer and they remove the impurities to send it back for us to use. We try and use the waste streams. So we extract the bromine out of the fiberglass. We then use that synthetic gas, and in time, it'll find its way into our combined heat and power plant to generate energy. So if we consider the facts, and we can reposition electronic waste as a resource rather than a waste, there's 100 times more gold in a ton of electronic waste than in a ton of gold ore. 100 times. Yet we only formally recycle 18% of our electronic waste around the world. It's expected. Would you throw away your gold, silver, or platinum jewellery? Probably not. But that is not true of electrical goods containing those same precious resources, which are expected to contain up to 7% of the world's gold at a value of over £7 billion. It doesn't take us long to calculate the environmental issues we can avoid through focusing on technology like this and using urban mining. And the time for change really is now. The United Nations predicts that by 2050, when many organisations and governments expect to be net zero, we'll be generating over 120 million tonnes every single year. As the saying goes, where there's a will, there's a way. Well, I came across a great example in Sweden. And Swedish citizens are really concerned for the environment. And so they developed some sophisticated techniques for recovering their domestic waste streams with astonishing results. They went from collecting 38% of their domestic waste in 1975 right the way through to over 99% in 2019. And that got me thinking, as we start to see that our resources become scarcer, will there be a time when we have to go and salvage this electronic waste from our landfills around the world? After all, it's only about 25 years until we'd have dug all of the gold out of the ground. That's why we can no longer employ an economy of take, make, consume, waste. The linear economy is gone. We have to focus on reduce, reuse, repurpose, recycle. We're trying to do that at the Royal Mint and demonstrating how that can be achieved with electronic waste, processing over 3,750 tonnes every year. That's the equivalent to the printed circuit boards out of about 24 million laptops. And I thought long and hard about what Newton would say we should be doing, and I came up with two things. I've already explained how he created his law of universal gravity. I think he would create a law on waste. Don't get me wrong, it's not entirely scientific, but what it would say is we should use the best available technology to recover our precious resources at source and in the area where they can be reused in a format they can go into new products. That would reduce our reliance on mined materials, but it would also have a positive impact on our CO2 and equivalent emissions. The second is somewhat easier. Do absolutely nothing. Don't upgrade to the latest phone. Don't upgrade to the latest laptop. make the most of the technology that you have. And of course, when it's served you its purpose, get it to the recycling centre, and hopefully it'll find its way to us in South Wales. If the decisions that we take today have a bigger impact than we might appreciate. Individually, they might seem small, but collectively, we can achieve a lot. In Newton's time at the Mint, we became the most respected mint in the world and the most efficient. And I think Newton would be proud of what we're looking to achieve today, using innovative technology to make gold from waste. Thank you.